Hello everyone, I'm back with another video, J2 Tutoring. My name is Jane Barish once again, and we are going to be talking about quadratics in more depth. Last time we talked about factoring, we did some intro on quadratics, how to solve them with factoring, as well as the quadratic formula, and using the discriminant. But this time we're going to talk about another technique, why it's pretty useful, and another form of writing a quadratic equation. So to start, we're going to talk about the basic form yet again. Sorry, that's supposed to be just an A. Okay, remember, this is the main form of a quadratic. We like to have it could equal any constant, but we'll make it equal to zero just for the sake of what we're doing. It's basically how you write one, right? So essentially, what we're going to do is we're going to show another technique of doing it called completing the square. I'm going to do this with an example. Now this one, I'm not going to lie, this can get a little tricky. A little tricky, but I promise it will be okay. Say I mean, we can make it. We'll make it a little bit different. We're not going to make it equal to zero, but I'm going to make it so that it kind of works. Actually, it doesn't have to. It's fine. All right, here we go. So we'll do something like this. So when something's not so easy, like this isn't very easy, because if I were to move this over, let's say, and this is not what you're supposed to do when you're doing completing the square, but let's say I move this over and I get like -3. You get something like this. Like, this is not going to work very well. You can use the quadratic formula. That will work. I promise that will work. But if you want to try something different, or the question asks for vertex form, which is what we're going to get into in a second, here's what you do. So you start from where we were, but this time you're going to move the other way. So you're going to go like this. You subtract 6 on both sides, right? So essentially, when you do that, you're now left with this. Now you're probably like, well, where do I go from here, right? How does this even work? Well, I'm going to create a square on the left side. That's essentially how this works. But remember, addition property of equality, when you add it to one side, you got to add it to the other because you got to keep everything kumbaya. It's got to be all the same. So here's what you're going to do. You're going to have to make a square out of this. Now, I didn't make this an even number, so this is going to be kind of messy, but that's okay. There's a phrase that people like to use. It's called have it, square it, share it. Essentially, what you're going to do, and it's all about the middle term. And share it just means adding it on both sides. We're going to go through it. So essentially, you have the middle, so you're at 5/2. You're going to square it, and then you're going to put it on the other side. So we're here, right? 5/2. Just like this is squared. And then it's going to be out of order, but it's okay. And then you're like, all right, well, then you got to add that to this side. So that's 25/4 on this side. So yeah, this is very messy, but I promise you this is how it's supposed to be. Now, this expression right here on this side, this is a perfect square polynomial right here. I just created it on this side, and it's equivalent to the original one because we have we added the square on both sides. So how do you know how to create this? It's whatever the half is becomes the inside. So if you notice, these two expressions are equivalent. This and this are the same. Okay. How did I know that this is the number that I needed? Well, it's the half, 5/2. And then you just add this on this side. So that's 12/4. So that's 37/4, which is a terrible number, but it's okay. Now, this is where things get interesting, right? Because you're in this sense now, and now you could just solve this by taking square roots. So like, all right, well, and this is what the square root would look like when you're doing it with the quadratic formula. Like you're here, and then you're like, all right, right, that's great. And then you just move this over. So now this is plus or minus. You got to remember that. This is plus or minus. Remember, two answers. So this is your answer at -5/2 plus or minus, and I'm just going to make it easier. It's going to be rad 37/2. And that's it. And now if you notice, remember quadratic formula, you have 2a, right? It's b squared minus 4ac all over 2a. 2 times 1 is 2. That's why they share the same denominator, because it's, right? So You see how it kind of comes together? If I were to make it in the way of a quadratic, you could even see what your discriminant is, right? That's your negative b is the negative 5 plus or minus the square root. The 37 is the discriminant that we went over last time, all over 2a. It's the same thing. We just completed the square. So that's a different form. That's a different way of doing it, right? Essentially. That's how you do that. Okay. It's have it, square it, share it. That's the main idea. Have it, square it, share it. You're going to have the middle. You're going to square it. You're going to add it to both sides. But you got to have all the constants on the right. That's how you create this. You have all the constants on the right. Instead of it being equal to 0, you put them on the right. Now, why is this useful? For a couple of reasons. One, if you forget the quadratic formula, and there's no factoring. Factoring is always your first line of defense. If you can factor, you should factor. Okay. But if you can't factor, then you should use the quadratic formula if you forget how to do this. Now, why would you ever do this over the quadratic formula? Well, essentially, I put the square root over it, but this step right here is exactly why you would. Because this is something, it's not exactly vertex form. You got to move the 37 over 4 over, but this is vertex form. And this is important because it tells you something about the graph, you know, this part of the graph, right? Obviously, it's not drawn to scale, and that's 0, 0, but for the sake of this, it's going to be your vertex is this is your x coordinate, so negative 5 halves. It's not, you know, it's not it's not positive 5 halves, but it's negative 5 halves, and then whatever this y value is. So your vertex is negative 5 halves and negative 37 over 4, essentially. Is what I'm saying. And that's important. Okay. Now, another cool thing you can think about is you're like, all right, well, what if you just want to know the x coordinate of this vertex? That's called the axis of symmetry. Okay. So the axis of symmetry is just where the parabola splits. So in this case, it would just be the y-axis in this poorly drawn picture. This is the axis of symmetry. How do you know it? It's the x value of the vertex, which is essentially negative b over 2a. So you have negative 5 over 2, which is exactly what our x-coordinate vertex is. So that kind of helps you um like narrow it down. It helps you check what your vertex is and if you did completing the square correctly. The thing is, you won't know what the y value is unless one, you plug it into the original function or you have vertex form. That's kind of the benefit of completing the square. You create vertex form as well as finding the axis of symmetry, as well as another technique in case you forget the quadratic formula. But the quadratic formula and completing the square will always work. I recommend the quadratic formula if you just want to solve it. Completing the square is cool if you want the vertex form. It'll always work, but if you get something like this where it's an odd number, I'm kind of happy it did an odd number because it didn't work out nicely. It still works. It's just the math is kind of icky. So, your call. But the main idea is have it, square it, share it. Remember that. That's how you create the square, and all the constants need to be on the right. Okay? You must add them to both sides as well. That's essentially the continuation of quadratics. Again, these videos are snippets. I do 1 or 2 examples, and then that's really it. I don't want to make it too long and keep you here all night. But if you'd like more teaching on it, if you'd like me to go more in depth, you could leave that in the comments for a future video, or you can schedule a lesson with me or one of our other tutors, and we'll be glad to help you more on the subject, whether you just want to pursue knowledge or you need help in school with any other topic. But I'll take suggestions always in the comments or on our site, j2tutoring.com. Please go to that if you would like to schedule a lesson. All right. Thank you and have a great night.